Hello students. So far we have done similarity of triangles, isn't it? So next let's start with another new concept known as areas areas of similar triangles. Areas of similar triangles. Now we know how to prove two triangles are similar. Now we'll go the next step further. If two triangles are already similar, then if, for example, let's take two triangle, let's say triangle ABC. Let's take triangle A, B, and C, and let's take another triangle. Let's take another triangle P, Q, R. We know how to prove the triangles are similar. Suppose if these two triangles are similar, then we can say an important result, that is area of triangle ABC divided by area of triangle PQR will be equal to, that is, if you take the ratios of areas of the triangle, it will be equal to squares of the corresponding sides, squares of the ratios of corresponding sides, that is AB by PQ the whole square, which is equal to BC by QR the whole square, that is equal to AC by PR the whole square. This is an important result that we can tell if two triangles are similar. Remember, we can use this only if the two triangles are similar. So the statement, there is an important theorem itself. Let's prove that. What is the statement? The statement of the theorem is statement the ratios of areas of two similar triangles. Remember, it's not any triangle, it is similar triangle. The ratio of areas of two similar triangles is equal to again the ratios of squares of corresponding sides. Okay, this is one result. There are two more results that we can tell if two triangles are similar. Now let's prove this theorem, that is, if two triangles are similar, the ratios of areas is equal to ratios of squares of corresponding sides. Let's prove this theorem. Okay. Okay, we have taken two triangles ABC and PQR which are similar. They are already similar. And we know what we have to prove, that the ratio of area of triangles is equal to ratio of squares of corresponding sides. That is, this is what we have to prove, isn't it? We have to prove this stuff. Okay. Now, since already they have given that the triangles are similar, we know that if two triangles are similar, we can write this, isn't it? Corresponding angles are equal. That is, angle A will be equal to, angle A will be equal to angle P, and B will be equal to Q, and C will be equal to R. You can write all these things because the triangles are similar. At the same time, we can also tell the corresponding sides, that is AB by PQ is equal to BC by QR, that is equal to AC by PR. We can write this stuff because the triangles are similar. Only if triangles are similar, we can write these two conditions. Okay. Now let's come to the proof of the theorem. In the proof, we have got statement and the corresponding reasons for it, isn't it? So let's bisect them. Okay. So now what we are trying to do is find the ratios of areas, right? Let's find that itself. So area of triangle ABC divided by area of triangle PQR. Okay. Now, if you want to find area of a triangle, what is required? How do you find area of a triangle? Area of a triangle is half into base into height, isn't it? But if you observe here, there is no height. So we have to construct height, isn't it? You can take any side as the base. We have already discussed this in the second part of the video, that you can take any side as the base of the triangle. Whichever side you take as the base of the triangle, from the opposite vertex, you should have a perpendicular line. So we don't have that. So let's construct that. So this will be in construction part. So we are drawing a perpendicular. So this will become height. Let's take it as PM. And let's also draw the perpendicular for the other triangle. This is the perpendicular. Let's take it as some N. Okay. Now remember, if this is a height also known as altitude, M is not a midpoint. Okay. Whenever we draw an altitude, do not consider M as a midpoint. It becomes a midpoint only in a special case. We'll discuss that later. Now, if it was a median, then M is a midpoint, N is a midpoint. Now, PM is an altitude, AN is an altitude. So, M and N are not midpoints. So, area of a triangle is found using the formula half into base. Let's take BC as the base. If I take BC as the base, it's very clear. AN will be the height. Similarly, I'll take half into the base will be QR. If QR is the base, then PM will be the height. So half and half gets cancelled. So we are left with BC by QR into AN by PM, isn't it? This is what we are left with. Remember, the theorem is done when we replace this AN. If you replace this AN, let me do the other side. See, what we have got is BC by QR into AN by PM, isn't it? Instead of this AN by PN, if I get BC by QR itself, then it will become BC by QR the whole square. That is one part of the theorem is done. If we prove for one thing, automatically the other two will become equal, because we have got this stuff, right? Here AB by PQ is equal to BC by QR, AC by PR. If we prove this, automatically the other two will become equal. So what we are trying to do is, we have got AN by PM here. If we replace this AN by PM as BC by QR, that is, if we prove AN by PM is equal to BC by QR, if we prove this, then our theorem is done. So that's what we are going to do. For that is, we have to prove BC by QR is equal to AN by PM, isn't it? For that, which two triangles should we take? Here, okay, here we won't get a triangle. So let's do it in another way. What let's do is, let's take the triangle ABN. In triangle ABN and triangle PQM, let me shade those two triangles. That is this triangle and this triangle. Let's try to prove these triangles are similar. Okay. So let's try to prove these triangles are similar. So very clearly, angle B is equal to angle Q, because from the data itself we have got it given. We have got it here, right? We can write this angle B is equal to Q because the triangles were similar. So it is given. Now similarly, angle N is equal to angle M because both are 90 degrees. Therefore, two angles are equal. Therefore, triangle ABN is similar to triangle PQM using AA criteria. Using AA criteria, these two triangles are similar. If two triangles are similar, we can also write this, isn't it? AB, corresponding sides are in proportion. That is, AB by PQ will be equal to BN by QN, BN by QM, which will be equal to AN by PM. Let's take this middle part out. Let's take it out. We don't need it. Okay. What we have got is, we have got that AB by PQ is equal to AN by PM. How did we get this? If two triangles are similar, then corresponding sides are in proportion. Corresponding sides are in proportion. Now, but we already know that from the given data, that AB by PQ is already equal to, if you observe from the given data, it is equal to BC by QR, isn't it? This is from given. This stuff is from given. Now, if you observe here, both the LHs are same. Therefore, the RHs are same. Okay, which implies, let me continue, which implies that the RHs are same. Okay, so let me continue, which implies AN by PM is equal to BC by QR. This will be axiom 1, isn't it? Things equal to same thing are equal to one another. Therefore, area of triangle ABC by area of triangle PQR, what we had earlier was, we had BC by QR into AN by PM, isn't it? We had BC by QR, I'm sorry, BC by QR into AN by PM. Now, BC by QR into AN by PM can be written as what? BC by QR, because we have already proved it here, isn't it? We have proved it here. Therefore, this gives us BC by QR the whole square. Sorry, it gives us that BC by QR the whole square. So if we have done for one thing, automatically the all other three things will become equal. That is, area of triangle ABC by area of triangle PQR will be equal to all the three things. That is AB by PQ whole square, BC by QR the whole square, which is equal to AC by PR the the whole square. Okay, let's look again what we have done. See, it is given, let me take another color. See, what was given was triangle ABC is similar to triangle PQR. If two triangles are similar, then we can write this and this. That is, corresponding angles are equal, corresponding sides are in proportion. We can write these two stuff. Okay, and this is what we have to prove. Triangle ABC, ratio of area of triangles, this is what we have to prove. Okay, how did we start? We started by taking area of triangle ABC by area of triangle PQR, which is found using the formula half into base into height. So half BC is the base, AN is the height. Half QR is the base, PM is the height. Half and half gets cancelled. We have got this stuff. BC by QR is equal to AN by PM. So I got to know that if I replace this AN by PM as BC by QR, the problem is done. For that, what we did was, we took the triangle ABN and PQM. So angle PB is equal to Q because it is given, and angle NM are 90 degrees. Therefore, we have proved two angles are equal. Therefore, the triangles are similar. If two triangles are similar, corresponding sides are in proportion. So using that, we got this. AB by PQ is equal to AN by PN. But already AB by PQ was equal to BC by QR. From observing these two, the LHS are same. Therefore, the RHS and RHS are same. Therefore, we got AB by BC, AN by PM is equal to BC by QR. I repeat, AN by PM is equal to BC by QR. We got this. Now substituting, earlier we had this, right? So substituting in that. So take out this AN by PM and replace it by BC by QR. So BC into BC, BC square, QR into QR, QR square. Therefore, it becomes BC by QR the whole square. So if you have done for one thing, automatically the other things also will be equal. Along with this, we can tell two important things. That is, Suppose if two triangles are similar, triangle ABC is similar to triangle PQR. If two triangles are similar, we have already got a condition, that is area of triangle ABC by area of triangle PQR is equal to squares of the corresponding sides, that is AB by PQ the whole square, BC by QR the whole square, which is equal to AC by PR the whole square. This is what we have proved. But we can also prove two more results, that is area of triangle ABC by area of triangle PQR is also equal to the ratio of altitudes, that is AM by PN the whole square. Let me show that. See, in the previous thing where we proved, this is what we proved, right? So here, just observe, in the last proof, in this step, we replace this AN by PM by BC by QR. Imagine we have done the reverse thing, that is, we'll keep this AN by PM as it is, we'll take out this BC by QR and replace it by AM by PN. So then what will become? The same theorem, exactly the same thing, but if we do one small change here, see what we did in the theorem was we replaced this AN by PM. Okay, we took this out and we replaced it by BC by QR. Now let's do the reverse thing. We replace this BC by QR as AN by PM. Okay, so what it becomes? AN by PM into AN by PM, that is AN by PM the whole square. What is this AN and PM? AN and PM are the altitudes of the triangle, isn't it? AN and PM are the altitudes of the triangle. Therefore, if two triangles are similar, okay, let me reverse it. It is AN and PM. Okay, which means ratios of areas of similar triangles is also equal to ratios of squares of corresponding, instead of sides we can replace it by altitudes. Okay, this is another important result that we can tell. We can also tell that area of triangle ABC by area of triangle PQR, it is also equal to, let's say let me use R. No, R is already used. Let me take some AX and PY the whole square. What is this? AX and PY are medians. So instead of altitudes, if we have medians, we can also say that ratios of areas is equal to squares of the corresponding medians. Therefore, we can say three things. One is corresponding sides, another one is corresponding altitudes, another one is corresponding median. That is, if you have got triangle like this, let's say A, B, C, and let's say we have got another triangle P, Q, R. So we can, let's say AX is a median, PY is a median. Then if these two triangles are similar, then we can also write this condition, that is AX by PY the whole square, where AX and PY are the medians of the triangle. Therefore, if triangles are similar, remember, if triangles are similar, we have got three different results. That is, ratios of the areas is equal to ratios of squares of corresponding sides. Let me write it separately. Let me write it on the new page itself. That is, if two triangles are similar, then ratios of areas of those two triangles is equal to, there are three things. First one is ratio of squares of corresponding, ratios of squares of corresponding sides, or we can also say that it is equal to ratios of squares of corresponding, let me write it properly, corresponding altitudes, or we can also say that it is equal to ratios of squares of corresponding medians. So we can have sides, or we can have altitudes, or we can have medians. These are the three important results that we can conclude if two triangles are similar. We can conclude only when the triangles are similar. Otherwise, we cannot use this. So in the next video, let's start with exercise problems based on this areas of similar triangles. Thank you, students.